Hey, in this video, we're going to talk about a couple properties of logarithms that make it really easy to solve equations with logarithms or evaluate logarithms. And this is one of the primary reasons why they're popular as well, because they have some nice properties that work together. So property one was mentioned in the last video, that if we have log base a of xy, then that's log of a of x plus log of a of y. And also we'll note in the previous videos, we had like log 2, or I just said log. Log a of x is just the inverse to f of x equals a to the x. So we're just sticking the base down at the bottom. And we'll do a small proof. We'll call it a proof, but it's mostly just a computation. So we'll start with a recall. That if we do e to the log a of x, this function, that's just the function that does nothing. So if we apply this to an equation, we didn't do anything at all. So we'll take log a of x plus log a of y. We are going to change it at first. We'll just I guess I should amend what I said right above as well. This is also the same as log a. That should be an a of a to the x. So that's the one on the right is the identity we're going to use. We're first going to exponentiate by a, and then use our properties of exponentiation. So that breaks up. That's the same as a log a of x times a log a of y. And then from up here, we know that that's going to cancel down to just be x times y. All right, so we're pretty close to where we need to be. Maybe pause the video and think about what's the next step we need to take. And a hint is we need to exploit this identity that it's an inverse function. Okay, so we had our original equation here, and we exponentiated it. So that actually changes the value. So we need to undo that exponentiation. So we just take the logarithm with respect to a of both sides. So that gives us log a of a to the log a of the x plus log a of y equals, and we'll do it to the other side as well, log a of xy. And then these two undo each other. And so we're just left with log a of x plus log a of y equals log a of x times y. And there we have it. So that's our first major property. Now our second one, or property 2, is that log a of 1 over x equals negative log a of x. This one is a bit simpler. Log a of x, log a of 1 over x is the solution to I guess we'll call it y equals 1 over x. Well, then that tells us that we can multiply x to the other side, divide a to the y to the opposite side, that we have x equals 1 over a to the y, which implies that x equals a to the negative y. All right. Well, now this y is the solution to a to the negative y equals x. So y equals negative y is going to be negative log a of x. But we also had from above that y had to be equal to this because y was initially the solution to a to the y equals 1 over x, which is log a of x. So that tells us that log a of 1 over x equals negative log a of x. So that's property 2. And with those two properties, we can really make everything run. All right, I'm starting to run out of space. So I'm just going to go to the side and write these down for us. All right, so prop 1, log a of xy equals log a of x plus log a of y. Log a of 1 over x equals log a equals minus log a of x. We have our, so this is property 1, property 2. We'll call this next one our inverse identity, where we have log a of a to the x equals x. A to the log a of x equals x. Okay. Now what we're going to do is use these 3 identities to talk about a couple more properties. So property 3, this is going to be our division property. Log a of x divided by y equals log a of x minus log a of y. This one's pretty quick. Log a of x divided by y equals log a of x plus log a of y, log a of 1 over y, which equals log a of x minus log a of y. So hopefully that loads. There we go. And our final property, property 4, is that log a of x to the k equals k log a to the x. This one's particularly useful when we're trying to take the logarithm of large numbers, because if you can recognize it as a power, then you can just boil it down to something smaller. And we'll do a quick proof for that. So log a of x to the k equals log a x times x times x, k times and that's log a of k. Sorry, log a of x, log a of x, k times, which equals k log a of x. So there we go. That was our property. So these 4 properties, I guess 5 properties, if we count the inverse identity, are going to be ridiculously useful when we're solving equations involving logarithms. They really make everything quite a bit easier. All right, so for now, that's it on properties of logs, but we'll see where they're used later. All right, see ya.